Let's work through an example that compares first-degree price discrimination, third degree, and a firm that does not engage in discrimination at all. When the firm does not engage in discrimination at all, it charges every customer the same price, regardless of how many units the customer purchases. We're going to deal with a simple world. The firm has 2 customers. Each customer is willing to purchase up to 10 units of the good. And the values for A for each unit decrease from 20 to 17, 14, 11, 8, 7, 5, 4, 2, and $1 as the number of units purchased increases from 1 to 10. The value to customer B goes $19, 18, 16, 15, 13, 12, 10, 9, 6, and 3. The value of a unit is the highest price that the customer is willing to pay for that unit. That means the customer A will pay $20 if they buy 1 unit. To get them to buy the second unit, you're going to charge them $20 for that second unit. If you charge the same price for all units, you've got to drop price 17 for both the first and the second to get them to buy 2 units. If you engage in first-degree price discrimination, you can charge them $20 for the first unit and then drop price 17 for the second unit and get them to buy both the first and the second unit. We're also told that average total cost is constant and equals 3.5 for all levels of output. We're going to answer 3 questions. What's the maximum profit when the firm does not engage in price discrimination? What's the maximum profit when the firm engages in first-degree price discrimination? What's the maximum profit when the firm segments the 2 customers into 2 submarkets? And finally, when is profit the highest? So first question, what is the maximum profit the firm can earn when it does not engage in price discrimination? Spend some time, form your own answer, stop the video while you're working, and when you get your answer, restart the video and see if your answer is the same as what I'm about to tell. The first thing I do is I figure out what marginal cost is. Marginal cost is equal to 3.5 for each extra unit of output when average total cost is constant and equals 3.5. Whenever average total cost is constant, marginal cost equals average total cost. You can check this by calculating marginal cost when output increases from 5 to 6, or you can use any other pair of output levels. You'll always get marginal cost is equal to 3.5. The next thing I do is use the information about values to construct the demand curve for the product. The first 2 columns of this table contain the demand curve. I see price going from 20 down to, what did it go down to? Went down to $1. And as price goes from 20, the quantity demanded goes from 1 up to 20. Any price higher than $20 makes the quantity demanded equal 0 because the values are because no one has a value that's higher than $20. But if the price is 20, customer A is willing to buy 1 unit because the value of the first unit to customer A is $20. When price dropped to 19, customer B wants to buy a unit because the value of the first unit to customer B is $19. Customer A is thinking they're getting a real deal. When price goes to 19, they'll continue to buy their first unit. And they're willing to pay 20, but only going to pay 19. This means they're going to be able to capture a surplus of $1. When price goes to $18, we now induce customer B to purchase the second unit. Customer B is getting a $1 surplus on the first unit they purchase, and customer A is going to now get a $2 surplus on the unit they purchase, but the total quantity demanded is equal to 3. We continue that process. Every time price decreases by $1, the quantity demanded increases by 1 unit. The next column in my table shows total revenue. Total revenue is simply the price charged by the quantity sold. We're going to assume here that the firm will sell whatever the number that consumers want to purchase. So any price times quantity 0 gives me total revenue 0. When price is 20, I can sell 1 unit. Means my total revenue is going to be $20. When price is 19, I can sell 2 units. 2 times 19 gives me a total revenue of 38, et cetera, et cetera. Total revenue rises to $110, and when price is 10 or 9, and then total revenue starts to fall as price decreases further. I know that profits maximize where marginal revenue equals marginal cost. I've already learned that marginal cost is 3.5. All I've got to do now is find where marginal revenue is equal to 3.5. Marginal revenue is the change in total revenue divided by the change in output. So the marginal revenue of having output go from 0 to 1 is going to be the extra revenue $20 divided by 1. Marginal revenue is 20. Marginal revenue of having output go from 1 to 2 is the extra revenue, $18, again divided by 1. Marginal revenue of the second unit is $18. Marginal revenue of the third unit is the extra revenue, 16, divided by extra quantity, 1. 16 divided by 1 gives me marginal revenue of 16. So given this nice linear demand curve, I get a nice linear marginal revenue function. Marginal revenue starts at 20, and it decreases by 2 every time output increases by 1. We want to find where marginal revenue is equal to marginal cost. I don't have a marginal revenue of 3.5. It turns out that when output is sort of lumpy like this, the profit maximizing level of output is the last output where marginal revenue is above marginal cost. As long as marginal revenue is above marginal cost, the firm's profit rises. So the firm wants output to go from 0 up to 9 because marginal revenue for each of those steps is greater than marginal cost. Profit falls if output goes from 9 to 10 because the marginal cost of 3.5 is higher than the marginal revenue of $2. So we now have the profit maximizing price is 12 and the profit maximizing quantity is 9. To find the maximum profit, all we've got to do now is find to find the profit at that level of output. The maximum profit is $102. When output is equal to 12 and price equals $9, then profit equals total revenue minus total cost. Total revenue is price times quantity. Total cost is average total cost times quantity. We could do some algebra. It's the difference between price and average total cost multiplied by quantity. 9 minus 3.5 times 12 gives me 5.5 times 12 gives me $66. So the maximum profit is actually $66. The maximum profit is $66. You can check this result by calculating profit for all output levels in the table. The next question is, what is the maximum profit when the firm engages in first-degree price discrimination? Take a minute, form your answer, and stop the video. When you've got your answer, start the video again and see if your answer corresponds with mine. With first-degree price discrimination, the price the firm can charge for each unit equals the value to the consumer for that unit. The firm can charge customer A $20 for the first unit, $17 for the second, etc. The firm shows the total revenue and marginal revenue under first-degree price discrimination. So again, if I don't sell anything, my revenue is 0. I can charge $20 and sell the first unit to customer A. If I keep that price to customer A at $20 for the first unit and charge customer B $19 for their first unit, I can increase my revenue from 20 to $39. The extra revenue, the revenue I was getting from customer A doesn't change, but I pick up additional $19 for the first unit I sell to B. I sell another unit to B, but now I get 19 for the first unit to B and 18 for the second unit for B. Means my revenue now goes from 39 to 57, and I continue on like that. In this case, total revenue is going to be the sum of the prices that people want to pay for each extra unit that I sell. Marginal revenue equals price for each extra unit. To find where I maximize profit, I got to find my marginal revenue equals marginal cost. Here we are. Marginal revenue is above marginal cost all the way to the 17th unit of output. No, I'm sorry. Yeah, all the way to the 17th unit of output. So the firm maximizes profit when output is equal to 17. We can find the maximum profit in that case. to be 144.5. When output 17, profit is total revenue minus total cost. We've already found total revenue by adding up the prices that people are willing to pay. We multiply average total cost by output to find total cost. The result is 144.5. Again, you can check this by calculating profit for all output levels in the table. The last question is, what's the maximum profit when the firm segments the two customers into two submarkets? Take some time, develop an answer, stop the video, come back when you're ready to compare your answers with mine. So what I've done now is I've broken the demand for customer A into a separate table. When price is 20, customer A will buy 1 unit. When price is 17, customer A will buy 2 units. On down the table like that. I find total revenue and marginal revenue. The marginal revenue of the first unit is 20. The marginal revenue of the second unit is 14. Marginal revenue of the third unit is 8. Marginal revenue of the fourth unit is 2. This means that the firm wants to increase output from 0 to 3 because marginal revenue is higher than 3.5. It does not want to increase output from 3 to 4 because marginal revenue is less than 3.5. And if we look at the profit, let's say excluding, if we look at the profit in that submarket, we'll get 31.5. A similar process for customer B, we find that the optimal level of output is 6 because the marginal revenue of the first through the 6th unit is higher than 3.5. The marginal revenue of the 7th, 8th, 9th, and 10th units of output is below 3.5. That means that profit's maximized when quantity is 6. And we calculate the profit at that level of output to equal 51. So when we segment the two markets, we'll make a profit of 31.5 in the A market, submarket. I'll make it a profit of 51 in the B submarket. And the total profit I'm going to earn is 82.5. This means that this example illustrates that the firm's profit is highest when it engages in first-degree price discrimination, second highest when it engages in third-degree price discrimination, and lowest when it does not engage in price discrimination. The table summarizes the results. First-degree discrimination gave us 144.5 profit. Third degree, the profit was 82.5. Without discrimination, the profit was only 66.